Welcome to the notes for the last problem on the notes for optimizing using quadratic functions. I just wanted to go over the last problem, which would have been on the second half of the front of page 3. And this was a problem about ticket prices and people as they're on a ferry passenger transport. So a ferry service transporting passengers to an island charges a fare of $10 and carries 300 persons per day. The manager estimates that the company will lose 15 passengers for each dollar increase in fare. So complete the table below. So we start out at $10 per passenger and the number of passengers. So our daily income is 10 times 300. So you just multiply $10 per passenger and 300 and get 10 times 300. And I'm leaving that factored for a second because I think you'll see how that's going to play out. So if we increase the number of dollars by 1, so this would turn out to be $11, then we're going to lose 15 passengers. So 300 minus 1 times 15, and so this is going to be 11, and 300 minus 15 is 285. So we multiply this number times this number. Okay, so if we add another dollar, then that's 300 minus 2 times 15. So they're going to lose 30, but we're going to keep that separated. So we're going to end up with 12. And 300 minus 2 times 15 is 270. If we add another dollar, then 300 minus, you guessed it, 3 times 15. So you can see the pattern coming down. And that's going to be 13 times, this is 45, so 300 minus 45 is 355. Okay, so if we just start counting up and we have an unspecified number, then 10 plus x, and this is going to be 300 times x times 15. So we had one passenger, 2 passengers and 2, 3 and 3, and then x, because we don't know how many passengers. So that's going to be 10 plus x and 300 minus, I'm just going to flip those and say 15x. And this is our overall equation for daily income, considering the number of dollar increases, which is x. So x, so this is kind of a let statement. X is the increase in fare per passenger. Okay, so to determine the maximum daily income that can be generated and the increase in the fare that would generate that income. It doesn't give us many hints there, but we know from our chart that daily income, and let's just put that as a D, is equal to 10 plus x and 300 minus 15x. All right, if you look at this carefully, I'm gonna actually rearrange this. I'm gonna bring this factor to the front. And I'm going to put x plus 10. So I've switched the order around, put each of those in descending order. Interesting. So we have something times x plus a constant, something times something x plus a constant. This is almost factored form. Now, we worked with these things before. What is different between this and a true factored form? And what's different is that the coefficient attached to one of these x's is not 1. So we're going to have to pull this guy out in front. So if we pull the negative 15 out, then we have an x here. And if we divide 300 times negative 15, we get a negative 20. And then that other factor remains the same. So this is the factored form. And how are we going to convert that to the vertex so that we can find the top of the parabola? Well, you guys know that this is R1, and this is R2, but we have to, it's minus R2, so that's a negative 10. So the vertex of the parabola is at x is equal to R1 plus R2 over 2, which is 20 plus a negative 10 over 2, which is 10 over 2, which is 5. So the vertex is at 5. So now we need to find the y that goes with that vertex. So I'm just going to plug in the 5. And I'm going to plug it in on this side as well. And so that's negative 15 times negative 15 times a positive 15. And that is going to be a positive 3,375. So the y-coordinate of our vertex is 3,375. Now we're going to get the equation for that parabola, which is, so a is equal to negative 15, which is, it's the same a in all of the forms, since that's factored form. And x minus the x-coordinate of the vertex, and y, or k, is the y-coordinate of the vertex. So the vertex points down, that's a negative 15. So the maximum daily income is $33.75 at x is equal to 5. And since x is the, so x is the number of increases, so the new, the maximum, so the price at the maximum is 10 plus 5, which is $15. Okay, let's have a look at that. I'm going to bring that up on the navigator so that you can see it. Okay, so our equation is 10 plus x times 300 minus 15x. Let's bring that up on the navigator. Okay, so this is the equation for the X is the number of price increases, and F sub 1 actually represents the income. And we can only see part of the parabola, but I'm going to go ahead and change the window to something reasonable. And let's say -5 and 10 is good, and 4,000. Let's say y min is -20, y max is 4,000. And let's see what we see. We do see the top of that parabola. And I wonder what this maximum is going to be. So I can actually, don't tell anybody, analyze that by using analyze graph. And sure enough, the maximum tells us the x-coordinate at that max. I'm going to move that up so you guys can see it. The x-coordinate is 5, and the maximum income is 3.38 times 10 to the third, which is 3375. So I hope this helps you do your homework, and please let me know if you have questions.